Welcome to Rayat Shikshan Sanstha's Rayat Online School Education Project for 11th Standard. We have already started studying the topic laws of motion, and we have already discussed revised Newton's laws of motion and discussed about inertial and non-inertial frame of reference. In this session, we'll discuss types of forces, work energy theorem, and principle of conservation of linear momentum. So to start with types of forces, we know that there are four fundamental types of force in nature. The first one is gravitational force. Gravitational force is the force between two masses. Force of attraction between two point masses separated by a distance r is directly proportional to the product of masses and inversely proportional to the square of the distance between them. We can have the formula F is equal to G m1 m2 upon r square. That is, if we have two bodies having masses m1 and m2, and if the distance between them is r, then the force of gravitation between them is G m1 m2 upon r square. Here G is universal gravitation constant, and its value is 6.67 into 10 power minus 11 Newton meter square upon kg square. This is the weakest force in nature, and it has got infinite range. The force is always attractive. We know that the famous example is planetary motion is governed by gravitational force. The force between sun and earth, the force between earth and moon. Newton's example of force between earth and apple. Prithvi and Safarchanda's example famous ate. The question is whether only earth attracts the apple or apple also attracts the earth. The answer is both attract each other with the same force, right? Because the force is F is equal to G m1 m2 upon r square. Earth पण सफरचंदाला तेवढ्याच जेवढ्या फोर्सने अट्रॅक्ट करते तेवढ्याच फोर्सने सफरचंद पण अर्थला अट्रॅक्ट करते. फक्त फरक असा आहे की सफरचंद it is having very small mass, so we see its acceleration. ते पडताना and earth being very massive, it doesn't move. ती आपल्याला जागेवरून हलताना दिसत नाही. So the force is between two bodies, and both bodies attract each other with the same force. पृथ्वीवरच्या कुठल्याही दोन ऑब्जेक्ट मध्ये पण ग्रॅव्हिटेशनल फोर्स आहे का तर आहे, but we don't feel it. Actually, this is the weakest force in nature, and that is why we observe it in case of very massive bodies, that is heavenly bodies. The second type of force is electromagnetic force. It is an attraction or repulsion force between electrically charged particles. It is stronger than gravitational force. Electric and magnetic forces were unified thing in the theory of electromagnetism. Life is practically governed by these forces: the force of friction, then elastic forces, viscous forces. These are all electromagnetic in origin. Under the action of these forces, there is deformation of objects that changes intermolecular distances, thereby resulting into reaction forces. This is also inverse square law. Electromagnetic force also follows inverse square law, as is done in gravitational force. The third fundamental force is strong nuclear force. This is the strongest force in nature, and it binds the nucleons inside a nucleus. It is short range force, that is, it acts only when the distance is less than 10 power minus 14 meter. This force is attractive force and it is charge independent. That is the strong nuclear force between two nucleons, that is proton-proton, is also attractive. Nuclear force between proton and neutron is also attractive. This is the strongest force in nature. असा प्रश्न पडतो की आपण असं म्हणजे म्हणतो की दोन प्रोटॉन हे पॉझिटिव्ह आहेत, तर त्यांच्यामध्ये देयर शुड बी रिपल्शन बिटवीन देम, राईट? पण जर ते दोन प्रोटॉन जर ते न्यूक्लियसच्या आतमध्ये असतील तर दॅट इज द रेंज इज शुड बी दॅट इज द डिस्टन्स बिटवीन देम शुड बी लेस दॅन 10 power minus 14 मीटर असं असेल तर न्यूक्लियर फोर्स बिटवीन टू प्रोटॉन्स इज attractive one. That is, if it is electromagnetic in origin, that is the distance between them is greater than 10 power minus 14, then that will be electromagnetic in origin. That force will be repulsive one. जसं आपण म्हणतो like charges repel each other. पण जर ते न्यूक्लियसच्या आतमध्ये असतील, the nuclear force between them is attractive one. आणि म्हणूनच दोन प्रोटॉन, though they are both are positive, reside in the same nucleus. The fourth type of fundamental force in nature is weak nuclear force. This we observe when there is interaction between subatomic particles that is responsible for the radioactive decay of atom, in particular beta decay. This is not as weak as gravitational force. This is stronger than gravitational force, but it is much weaker than strong nuclear force and electromagnetic force. The range of the weak nuclear force is 10 power minus 16 meter. All these four forces are real forces in nature. Real forces manje they arise because of interaction between two bodies or two objects. You can categorize the forces into contact and non-contact forces. Non-contact forces are, you do not need any physical contact between the two bodies for two bodies. These forces are non-contact forces. Gravitational force, between sun and earth there is no physical contact, still the force is there, gravitational force is there. Between two charges, though there is no physical contact between two charges, they attract or repel each other. So even between two magnets, there is no physical contact, still the two magnets attract or repel each other. So these are non-contact forces. There is no physical contact between two objects. And contact forces are force of friction, forces occurring during collision. The two bodies touch each other and then the forces are contact forces. One more way of distinguishing between the forces is real and pseudo force. Just now we have seen real forces have their origin in the interaction between two objects or two bodies. And pseudo force, yesterday we have seen the example of pseudo force, that is a car. We had considered a non-inertial frame of reference of car. जेव्हा आपली कार कॉन्स्टंट वेलॉसिटीने मूव्ह होत होती, म्हणजे ऍक्सेलरेशन 0 होतं, तेव्हा the person in the car was sitting in the inertial frame of reference, so it did not experience any pseudo force. But when our car's velocity was changing, जेव्हा तिचा वेग बदलत होता, that means it was accelerated frame of reference, it had acceleration. That time the person sitting in the car was sitting in the non-inertial frame of reference, and so it experienced a pseudo force. That is, the jerk that it was felt. हे आपलं example last session मध्ये बघून झालेलं आहे. Now we'll have one more example. We'll have an example of a lift. Suppose this is a lift and a person is standing in the lift. The lift is a frame of reference, and if the lift is a frame of reference, if it is moving with constant velocity, it will be inertial frame of reference, and the person in the inertial frame of reference will not experience any pseudo force. If the lift is accelerating, then the person, that means its velocity is changing, then the person in the lift will be in the non-inertial inertial frame of reference and will experience a pseudo force. आता लिफ्टचं ऍक्सलरेशन कधी होतं, जेव्हा बंद असलेली लिफ्ट सुरू होते तेव्हा तिची वेलॉसिटी 0 पासून काही कॉन्स्टंट वेलॉसिटी पर्यंत वाढते, म्हणजे तेव्हा ती ऍक्सलरेट होते. किंवा चालू असलेली लिफ्ट आपण बंद करतो तेव्हा तिची वेलॉसिटी जी कॉन्स्टंट असते ती 0 होते, म्हणजे लिफ्ट सुरू करतो आणि बंद करतो तेव्हा काही काळापुरती ती लिफ्ट नॉन इनर्शियल फ्रेम ऑफ रेफरन्स असते, आणि जेव्हा ती कॉन्स्टंट वेलॉसिटीने मधल्या काळात मूव्ह होते तेव्हा ती इनर्शियल फ्रेम ऑफ रेफरन्स असते. सो जेव्हा आपण लिफ्ट सुरू करतो आणि बंद करतो तेव्हा ती नॉन इनर्शियल फ्रेम ऑफ रेफरन्स असते. And so a person sitting in the non-inertial frame of reference, that is a person standing in the lift, experiences a pseudo force. We shall consider the forces acting on this person, which is in the non-inertial frame of reference when the lift is accelerated. The weight of the body will act in the downward direction mg. समजा लिफ्ट वरती मूव्ह होतीये आणि तिची वेलॉसिटी वाढतीये, म्हणजे लिफ्टचं ऍक्सलरेशन आहे इट इज इन द अपवर्ड डिरेक्शन. लिफ्टचं ऍक्सलरेशन विच इज नॉन इनर्शियल फ्रेम ऑफ रेफरन्स is in the upward direction. So this person in the non-inertial frame of reference will experience the pseudo force exactly opposite in direction. म्हणजे या जर ते असं आहे ma, a is the acceleration of the lift, so ma pseudo force of same magnitude but opposite direction, it will act in ma in downward direction. Sorry, a nahi, m nahi, a is the acceleration of the lift in the upward direction. So या माणसावर force act होईल pseudo force ma in the downward direction. So total force on the body will exert on the floor will be m a plus g. So the person will feel a bit heavier. त्याला असं वाटेल आपल्याला कोणी तरी खाली प्रेशर दाबतंय. And this is not imaginary. You can actually put a weighing scale and note down the weight, increase in weight. Similarly, जर lift a acceleration ने downward accelerate झाली असती तर this person would have experienced a pseudo force ma in upward direction. And in that case, the weight that we have measured on the weighing scale would have been mg minus ma. आणि माणसाला जरा हलकं वाटलं असतं. He would have felt lighter. Now differentiate between real and pseudo forces. We can differentiate between real force and pseudo force. A force which is produced due to interaction between two bodies is real force, and a pseudo force is the one which is experienced by the observer because the observer is in the non-inertial frame of reference. Real force obeys Newton's laws of motion. Pseudo force do not obey. Pseudo forces do not obey Newton's law of motion. The examples we have already seen. Example of car we have seen. Example of lift we have seen. Similarly, the example of this centrifugal force is an example of pseudo force. We can categorize the forces into conservative forces and non-conservative forces also. Let us see how. सुरुवातीला एक एक्झाम्पल घेऊया. समजा माझ्या हातात एक दगड आहे आणि मी तो खाली सोडून दिला. माझ्या हातात असताना दगडाकडे टोटल एनर्जी काय आहे? कायनेटिक एनर्जी त्याची 0 आहे आणि टोटल एनर्जी इज ओनली पोटेन्शियल एनर्जी. व्हेन आय रिलीज इट, तो बॉल खाली आदळतो जमिनीवर, तेव्हा त्याची टोटल एनर्जी किती असेल? कायनेटिक प्लस पोटेन्शियल. म्हणजे काही पार्ट ऑफ पोटेन्शियल एनर्जी व्हेन इट वॉज इन माय हँड, त्याची जी पोटेन्शियल एनर्जी होती त्यातला काही पार्ट इट गॉट कन्वर्टेड इनटू कायनेटिक एनर्जी. बट व्हॉट अबाउट इट्स टोटल एनर्जी व्हेन इट हिट्स द ग्राउंड? इथे आपण एअर रेजिस्टन्स वगैरे सगळं 0 कन्सिडर केलेले. ओनली वी आर थिंकिंग ऑफ द रोल प्लेड बाय ग्रॅव्हिटेशनल फोर्स. So what we observe is the total energy is the same. हातात असताना कायनेटिक प्लस पोटेन्शियल जेवढी होती तेवढीच एनर्जी जमिनीवर when it hits the ground. Total energy. That is what is conserved. Its energy is conserved. Potential energy part of potential energy got converted into kinetic energy, but the total energy is conserved. So thus gravitational force is conservative force. See this line, during the black line, during work done by a conservative force, the mechanical energy, that is sum of kinetic and potential energy, is conserved. Work done is completely recoverable. म्हणजे आपलं कायनेटिक एनर्जी इज ग्रॅव्हिटेशनल फोर्सने केलेलं वर्क आहे ना. पोटेन्शियल एनर्जी गॉट कन्वर्टेड इनटू कायनेटिक एनर्जी. सिमिलरली kinetic energy can be converted into potential energy. So gravitational force and electrostatic force, these are the examples of conservative forces where work done is completely recoverable. We need to note one more thing about conservative force. त्याच्यासाठी एक एक्झाम्पल बघूया. जमिनीवरचा पडलेला एक दगड मी उचलून टेबलावर ठेवला. तर so I did some work. That work then got stored into potential energy of the stone. I did work against the gravitational force, right? त्या दगडाच्या potential energy मधलं change when we find out, we simply think of the difference in the potential energies of the 2 points. तो दगड कुठल्याही मार्गाने आणला तरी देखील the potential energy between the 2 positions, that is when it was kept on the table and when it was on the ground, is same. So म्हणजे work done by against a force, conservative force, is independent of the actual path followed. This is one of the feature of the conservative force. So work done is stored as the potential energy. So dW is equal to F dot dx is equal to minus du, or du is equal to minus F dot dx. These are the formulae used while doing calculations. If you have understood conservative forces, it's very easy to understand non-conservative forces. If work done by or against the force is dependent on the actual path, the force will be non-conservative one. Work done by non-conservative force, in that case mechanical energy may not be conserved. Work done will not be recoverable, that is frictional energy, air drag will be there. Work done against these forces appear as heat, sound, light, etc. Now let us learn about something about work done by a variable force. Work done by a force formula we know W is equal to F dot ds, that is Fs cos theta. Here the force and displacement are constant and finite. Theta is the angle between vector F and vector S. This formula will not be able to readily apply when the force is variable. So what we will have to do is, we will have to have dW is equal to F dot ds and then integrate. Where will be this force will be variable. म्हणजे आता बघा, समजा gravitation, we are doing work against gravitational force. किंवा work is done by the gravitational force. म्हणजे खूप infinite distance वरून एखादा ऑब्जेक्ट पृथ्वीवर येतोय. तर the gravitational force is not constant. जवळच्या हाईटला gravitational force खूप जास्त असेल तर खूप लांबच्या हाईटला gravitational force कमी असेल. जेव्हा वर्क करणारा फोर्स कमी असतो तेव्हा वर्क डन विल बी लेस and force suppose it is more, work will be more. So अशा वेळेला same thing viscous fluid च्या बाबतीत पण बोलता येतं, because they are speed dependent. स्पीड वर अवलंबून असतात. जर वस्तूची स्पीड जास्त असेल तर विस्कस फोर्स जास्त असेल. So अशा वेळेला work done by a variable force, what we have to do is that we shall see now. Now suppose the variable force is like this. See, this is force axis, this is displacement axis. The force is varying like this. And the displacement, now when the force varies like this, the displacement done is say S1 here, S1. So when the force is varying like this, the displacement done is this. So we'll find out the small work dW, dW1 done when the force varies from the force varies like this and the displacement done is this. So this is the value of the force that we will have, and multiplied by this displacement will be area under this curve. This will be dW1. When the force is changing like this, we will consider this as the value of the force and displacement is this. So dW2 will be force into displacement, this displacement, that is this, it will be this area and this area. So total work done dW1 plus dW2 will be area, this area, that is area under the curve. And total work done will be F dot ds, where from, so basically integration gives the area under the curve. That is why we can use integration to find out the work done. That is, and the limits will change from ds1 point s1 to s2. So work done by the variable force can be found out by finding out area under the graph F against displacement. So that gives you the work done by a variable force. Same way, if a force is varying like linearly variable force, varying like this, see it is changing, and this is the displacement. The area under of the trapezium ABQP will give the total work done when there is a displacement from P to Q. Now we have to see work energy theorem, the same thing that we have learned. मगाशी जेव्हा आपण कंझर्वेटिव्ह आणि नॉन कंझर्वेटिव्ह फोर्स बघितलं तेव्हा थोडाफार हा प्रकार बघितलेला आहे. that we are going to sum up into work energy theorem. Consider the same example of a body falling down. If you remember, if there is a decrease in potential energy due to conservative force, for example, it was gravitational force, it is entirely converted into kinetic energy. बॉल जेव्हा आपण दगड जेव्हा खाली सोडला तेव्हा त्याची पोटेन्शियल एनर्जी कायनेटिक एनर्जी मध्ये कन्वर्ट झाली. So work done by a force appears as a kinetic energy. Similarly, if an object is moving against a conservative force, its kinetic energy decreases by an amount equal to work done against the force. This principle is called work energy theorem for conservative forces. Problem Shodotana will have to use formula. It is change in kinetic energy, half mv square minus half mv square. Initial kinetic energy minus final kile. We could have done it final minus initial also. See, half m common kadla u square minus v square is equal to half m. V square is equal to u square plus 2s. The formula वापरल्यामुळे we have got this u square minus v square as 2 acceleration minus a into s. A is acceleration. 2 got cancelled, so it is ma into s. It is same as force into displacement. This is mathematical part. So work done, that is force into displacement, is equal to change in kinetic energy. That is what is work energy theorem for conservative forces. Now I shall see this principle of conservation of linear momentum. Actually, Newton's second law of motion says F is equal to dp by dt, right? Force is equal to change in linear rate of change of linear momentum. Now, see now if this F is 0, that is force acting on the system is 0, this dp by dt will be 0. dp by dt is 0, as dt cannot be 0, dp, that is change in momentum, will be 0. And change in momentum is 0, that means p is constant, same, it will not change. So p is constant. Thus, the total momentum of an isolated system is conserved during any interaction. This we can put in other words also. If the net external force acting on the system of bodies is 0, then the total momentum of the system is conserved or remains constant.